Hello students, today we are going to discuss a very important topic from inorganic chemistry, that is coordination compound. So at first we discuss what is chemical compounds. So we know that the chemical compounds are classified as first order compound and the higher order compound. So first we discuss the what is first order compound. So first order compound are those compounds which are combined of one cation and anion by covalent or ionic linkages. So what is higher order compound? Higher order compound are mainly classified as double salt as well as coordination salt. So what is double salt? K2SO4 dot Al2SO4 Al2SO4 whole 3 dot 24H2O. It is the molecular formula of potash alum. When the potash alum is dissociated in water, it forms 2 potassium ion, 4 sulfate ion, 2 aluminium 3 plus ion, and the presence of these ion are chemically designated. But in case of coordination compound, what is coordination compound? Coordination compounds are mainly comprises of coordination bond. So let us first discuss about what is coordination bond. Coordination bond, ligand to metal electron donation. We know that the ligand is the electron rich center as well as the metal is the electron deficient center. So when like chlorine is donates its 2 electron to outermost orbital of a metal atom, it forms a bond. So in this bond, the 2 electrons is shared by only chlorine atom. This type of bond are known as coordination bond. So in the periodic table, the D block element are of variable oxidation state. So we write the first row of transition element. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, and zinc. What is the electronic configuration? What is the valence shell electronic configuration of those elements? That is, in case of scandium, 3D1,4s2. In case of titanium, the electronic configuration is 3D2,4s2. Vanadium, 3D3,4s2. Chromium is 3D4,4s2. In case of manganese, it is 3D5,4s2. For iron, it is 3D6,4s2. For cobalt, 3D7,4s2. And for nickel, 3D8,4s2. For copper, it is 3D9,4s2. And for zinc, this is 3D10,4s2. To discuss the bonding of the coordination compound, at first we must remember those electronic configuration. So let us discuss some bonding parameters of the coordination compounds. So PtCl4 2 minus, PtCl4 2 minus. At first we determine the charge of the oxidation state of the platinum ion. What is the oxidation state of platinum ion in case of platinum chloride, PtCl4? So we know that nickel, palladium, platinum are present in a same group. So what is the electronic configuration of nickel? Nickel, the valence shell electronic configuration of nickel is 3d8,4s2. So what is the valence shell electronic configuration of palladium? That is 4d8 5s2. 4d8 5s2. And what is the electronic configuration of platinum? That is 5d8 6s2. So here we know that the chlorine present in nature as Cl minus chloride ion. So each chlorine atom contributes single negative charge. So overall 4 chlorine atom contributes -4 charge. So what is the charge of the platinum? Let us consider the charge of the oxidation state of the platinum is X. And we know that, and we see that overall charge of the complex is -2. So X plus -4, that is the overall charge is -2. So X minus 4, that is -2. So X equals to 4 minus 2, that is 2. So platinum present, the oxidation state of platinum is +2. So platinum electronic configuration 5d8 6s2. So what is the electronic configuration of platinum 2? When platinum 2 is formed means 2 electron is liberated from the outermost orbital of the platinum atom and it forms 5d8. So d orbitals, 5 shells are there, 5d, 8 electrons is present in 5d. So at first the electrons are occupied by singly occupied electron 1, 2, 3, 4, 5. Then the electron is doubly occupied 6, 7 and 8. Then 6s, the vacant 6s orbital is there and the vacant 6p orbital is also present. So our target is to form PtCl4, means here 4 platinum chlorine coordinate bond is there. Means 2 electrons in the formation of this bond, 2 electrons is donated by chlorine to the platinum metal to its outermost orbital. So chlorine, we know that chlorine is a very weak ligand. So the unpaired electron do not paired up. So the platinum ion, so the platinum chloride Cl minus is donates its electron from the 6s orbital. So 4 chlorine atoms are there. So Cl minus, 2Cl, 3Cl and the 4Cl minus. So what is the hybridization is there? We see that the hybridization is sp3 hybridization. And what is the magnetic behavior of this compound? What is the magnetic behavior? We know that the magnetic moment mu is equals to under root of n into n plus 2 Bohr magneton, where n is equals to number of unpaired electron. N equals to number of unpaired electron. So we see that in case of PtCl4, there is a presence of 2 unpaired electron. So the value of N is 2. So what is the value of mu? That is under root of 2 into 2 plus 2. That is under root of 8. It is approximately 2.87 Bohr magneton. So the compound is paramagnetic in nature. The compound is paramagnetic in nature. Let us discuss another example of bonding. That is Ni Cn whole 4 2 minus. So at first we can determine the oxidation state of nickel. We know that the cyanide always present in -1 oxidation state. So each cyanide ion contributes -1 charge. So 4 cyanide contributes overall -4 charge. Let us consider the oxidation number of nickel is X. So X plus -4, that is the overall charge of the complex is -2. So here X equals to 4 minus 2, that is 2. So nickel present in +2 oxidation state. So nickel, the valence shell electronic configuration of nickel is 3d8 4s2. The electronic configuration of nickel 2 plus, that is 3d8. So 3d, 5d subshells are there. Then 4s orbital is vacant and another 4p orbital is also vacant. So 3d8. So electrons are paired according to the Hund's rule. Means at first only electrons are paired by 1 and then unpaired, then paired 5, 6, 7 and 8. So 3d8. We know that cyanide Cn- is a strong ligand. So when a strong ligand is present, then the unpaired electron of the metal easily binds up and paired up as soon as possible because the ligand is very strong. So at first, in presence of Cn-, this unpaired electron is paired up to 4, 6 and 8. 3d, 4s is already vacant and 4p. So here the cyanide ligand donates its electron to the metal from the inner D shell because one inner D shell is vacant. So one Cn- donates in D shell, Cn- and Cn-. 4 Cn- donates this electron to the outermost orbital of the nickel and forms NiCN4 complex. So we see that the hybridization is dsp2, means here the inner d orbital is involved, means nickel Cn4 is formed a inner orbital complex. When the inner d orbital is involved in hybridization, then inner orbital complex is formed. But when
the outer d orbital is involved in hybridization, the outer orbital complex is formed. So when dsp2, when the hybridization is dsp2, what is the structure of the compound? What is the structure of the molecular complex? We know that when the hybridization is sp3, the structure of the molecular complex is tetrahedral. Tetrahedral. Coordination number Cn is 4. Coordination number 4, but the hybridization is dsp2, then the structure must be square planar in nature. Square planar. So square planar means nickel is present in the center and 4 cyanides are present here. So this is a square planar nickel complex. So what is its electronic, what is the magnetic behavior of the complex? Either the complex is paramagnetic or diamagnetic. We see that in presence of strong ligand Cn-, all the unpaired electrons are easily paired up. So here, no unpaired electron is present in the complex. So the complex is diamagnetic in nature. Diamagnetic, magnetic in nature. And due to the absence of unpaired electron, the mu value is also 0. So we discuss some example about the coordination number 4. Now we discuss some complexes with coordination number 6. Nickel OH2 whole 6, nickel OH2 whole 6, 2 plus. So nickel OH2 whole 6, 2 plus. So we know that the water is a neutral ligand. So overall charge, the oxidation number of the nickel, that is plus 2. What is the outermost electronic configuration? For nickel, the outermost electronic configuration is 3d8 4s2. For nickel 2, the outermost electronic configuration is 3d8. That is 3d 1, 2, 3, 4 and 5. Then the electron is paired up 6, 7 and 8. Then 4s and 4p orbitals are also present. We know that the water is a very weak ligand. So no electron pairing occurred. So there is a presence of one 4d orbital because it is a octahedral complex. 1, 2, 3, 4, 5. So water donates its electron to the nickel, to the outermost orbital of the nickel from the 4s orbital. So water, 6 water molecules are present in a complex. In this complex, 3, 4, 5 and 6. So we see that the hybridization is sp3
D2, sp3d2, and the structure is, when the coordination number is 6 and the hybridization must be sp3d2, then the structure must be octahedral. And what is the magnetic behavior of the compound? We see that there is the presence of two unpaired electrons. So previously we discussed what is the formula of magnetic moment? Mu. Mu equals to under root of n into n plus 2 Bohr magneton. What is the value of n here? There is the presence of two unpaired electrons. So n equals to 2. So mu equals to under root of 2 into 2 plus 2 Bohr magneton, that is under root of 8, is equals to approximately 2.87 Bohr magneton. So the compound is paramagnetic in nature. So the compound is paramagnetic in nature. And the octahedral complex means nickel is present in the center of the octahedron and 6 water molecules are present each corner of an octahedron. Okay. Then we discuss another example of octahedral complex in presence of strong ligand. So K4 FeCN whole 6 K4 FeCN whole 6. It is a complex. So in the outer part of the complex, there is the presence of 4 potassium ion. So potassium is present in the group 1 in the periodic table. So potassium is always, the oxidation number of the each potassium ion is +1. So here 4 potassium ion is present. So overall charge is +4. So the other part, the complex part, overall charge of the complex is must be -4. So at first we calculate the oxidation number of the iron. So let us consider the oxidation state of iron is X. And we know that cyanide always present in Cn- state. So each cyanide contributes -1 charge. So 6 cyanide ions contributes overall charge of -6. So X plus -6, that is equals to -4. So what is the value of X? X equals to 6 minus 4, that is 2. So the oxidation state of iron is +2 for this complex. So iron, what is the electronic configuration? What is the outermost electronic configuration of the iron? That is 3d6 4s2. And here iron is present in +2. So 2 electrons are liberated from the outermost orbital, that is 4s, and the electronic configuration is 3d6 for iron 2. So 3d 4s 4p and 4d. So 6 electron is present in the 3d orbital. So electrons are paired according to the Hund's rule. So 1, 2, 3, 4 and 5. The 6th electron paired up. And 4s, 4p as well as 4d orbital is vacant. But here cyanide is a strong ligand. Cyanide is a strong ligand. So we know that when strong ligand is present in a molecule, in a molecular complex, all the unpaired electron are must paired up. So here 4 unpaired electron is present. So in presence of cyanide, in presence of strong cyanide, all the unpaired electron are firstly paired up. This four S vacant and 4p also vacant. So cyanide donates its electron from the inner d shell because 2 inner d orbital is already vacant. So cyanide, 6 cyanides are present, Cn minus 1, 2, 3, 4, 5 and 6. So what is the hybridization? The hybridization is D2sp3. Means here the inner d orbital is involved in hybridization. So the hybridization is sp3 and it signifies the formation of inner orbital complex. So when the coordination number is 6 and the hybridization is D2sp3, the structure must be octahedral in nature. The structure must be octahedral in nature. And what about the magnetic behavior of the complex? We see that all the electrons, in presence of strong ligand, all the electrons are paired up. So the compound is diamagnetic in nature. No unpaired electron is present. So the now n value is 0. So also magnetic moment value is also 0 Bohr magneton. So today we are mainly discuss about the bonding pattern of the coordination compound. In our syllabus, only 2 coordination number system are there. That is coordination number 4 and coordination number 6. In coordination number 4, 2 types of structures are there. When the hybridization is sp3, the structure is tetrahedral. But when the hybridization is dsp2, the structure is square planar. And for coordination number 6, when the hybridization is sp3d2, as well as when the inner orbital complex is formed, d2sp3 hybridization, and in both cases the structure is octahedral. So today we conclude our discussion. Thank you.